Hello and welcome. Today we'll be looking at elongation of a taper bar of a rectangular cross section. First, we look at the diagram above. We are having a taper bar from this taper from here to here to here. But if you look at this other side, so we are looking at the taper bar of a rectangular cross section. All right. So now to solve this, you see we have already write what V1 is. The V1 here is the width at bigger end, and V2 is the width at the smaller end. Length is the length of the what of the bar itself. YP is the applied axial tensile load, and P is the thickness of the bar. All right, this thickness here can also be as well here. So, I just decided to put it here. Alright, so now ds here is equal to the length of the strip, or de here means differential element, and b here is the width of the strip or differential element. So for us to do this, we know that from deformation formula, we know that the L equals to PL all over what? A E. We would have applied this formula directly to solve this, but our area will be having problem with our area because we don't have a uniform area. As we move from this point to this point, you see the area keep increasing. So that is why you see you notice we don't have a uniform area. The area varies. So that is why we cannot directly apply this formula to solve this. Now, for us to solve this, we are going to consider a differential element, which is also known as a strip. This will section any part of the rectangular cross section on the paper bar that you are seeing, and try to section here, yours at this side, and try to section yours at this side. For me, I section this one. So B is the diameter of the strip, S is length of the strip, and P is the thickness of the you can see we said P is the thickness of the bar. Understand? But the thickness of this bar is also the same as the thickness of the strip. Take note of that. All right. So now for us to continue with this, we are going to look for area. But how are we going to look for the area of this differential element? Because we want to consider the deformation of this differential element. After we've gotten the deformation of the differential element, then we integrate it for us to get the total elongation of this rectangular cross section. All right, for us to get the area, we are going to look for the diameter. We are going to look for B. This the uh, this the width of the strip. We are going to look for the width of this differential element. So how do we look for this? Using unit formula, this unit method, so that our B is equals to what? B1. B1 minus B1 minus B2 all over L, everything multiplied by what? By S. All right. So that is how to look for our width of the strip. All right. So now the next thing is we are going to replace what we have here with K. Okay, let K be equal to B1 minus B2 all over L. And B equals to B1 minus KS. All right. So if we do that, we are going to substitute this now. But mind you, this is not the area. You know, the area is nothing but what? The area of a rectangle is what? That is the thickness. So area equals to width times thickness. So now that we have the width of the differential element, so we are going to replace this here. We are going to have area equals to, don't forget, we are considering the area of the differential element, not the area of the whole bar. All right. So and the area of this differential element is going to be the width times what? All right. So now we've gotten the width of the differential element to be B1 minus KS. So if we put it here, we are going to have B1 minus KS multiplied by what? Multiplied by T. So we put that here now. We are going to get the deformation of the differential element. So it means L will be equals to PL all over what? Area. Our area is what? B1 minus KS all into what? Into T. Then multiply by what? Multiply by E. So what we have here is the formation of the differential element. But we are not done. We said we want to consider the differential element. So it therefore means the length of our differential element is the S. It means our L here will be equal to what? The X. So it means that the differential element is taking L to be equal to. So the proper way of writing this will be Ps all over what? B1 minus Ks to T then P. So now this formula here is formula for our differential element. All right. So now we are going to integrate this so that we can get the total information, that is the total elongation of this bar. I'm going to move from the bottom to the top. This will integrate from 0 towards the L. The L will be equals to the integration from 0 to L of PDS all over 1, all over B1 minus KS PE. All right. You can see we are integrating in respect to what? In respect to X. So it means P all over TE become a constant. We are going to come to the back of this equation. Then we are going to have this as L to be equals to P all over TE, then integration from 0 to L of the S all over what? All over B1 minus what? KS. We are going to clean it. So for us to integrate this, we are going to take our U. Okay, let U be equals to B1 KS. Then we differentiate U in respect to S. U all over the S will be equal to minus K. All right. So we make the S the subject. We're going to have the S to be equals to minus 1 all over K. All right. So from there, I can therefore go back to formation now is going to be equals to P all over what? All over TE, equation from 0 to N of 1 all over U multiplied by the S, but our the S is equal to what? Minus 1 over K. All right. So we are integrating in respect to U now. So it means minus 1 over K will come to the back. So this will be equals to minus P all over what? All over TE K, then integration from 0 to L of the U all over what? All over U. All right. And if you integrate the U all over U, you are going to get link U. All right. So now L will be equals to minus P all over T E and K into what? Into link of U. Then we are moving from 0 to what? Don't forget, our U is equal to what? B1. So I can write this. You can write this as L to be equals to minus P all over what? All over T E into link of what? From 0 to, sorry, U. You already know that our U is uh, equals to B1 minus B2 all over what? All over uh, all over B. No, sorry, all over S. So we are going to take, so we have B1 minus KS. We are moving from 0 to what? To, that is what our U is. Finish. That is what our U is. All right, so now next thing is we are going to substitute the upper and the lower limit. We are going to have minus PEA. We are going to have this as this. So now we substitute that. We're going to have ln of B1 minus KL minus ln of B1 minus K into 0. Close the bracket here. Have this. All right. So now the L equals to minus P all over TE K. Then we open this. We know 0 times K is 0, right? Then B1 minus 0 is B1. So everything here will be what? Ln of B1 minus KL minus ln of what? Ln of B1. Right. So from here, don't forget, we also said that our K is equal to B1 B2 all over 1. By the time I substitute that here, I'm going to have my DL equals to minus P all over 1. All over TE multiplied by K is P1 minus P2 all over 1 L into ln of B1 minus K. Our K is B1 minus B1 minus B2, B1 minus B2 all over 1, all over L. Then we are going to have L here, then minus ln of B1. This is what we are going to have. All right. Then you are going to observe carefully that this L here will go with this L here. And if we open the bracket, we open that bracket there, we will have L to be equals to minus P all over TE into B1 minus B2 all over L into, we open this bracket, I'm going to have minus B1 plus B2. B1 will go with B1. There will be left with B2, left with ln of B2 minus ln of B1. So, all right. So now again, know that what we have here, by use this minus to multiply this bracket, we're going to have the L equals to this L will go up, and we are going to have PL all over TE into what? Into B1 minus B2 into minus times this, we are going to get minus ln of B2 minus times this, we are going to get plus ln of B1. Now you close your bracket. So we can further write this as ln of B1 minus ln of B2. So we can rewrite this as ln of B1, ln of B1 minus ln of B2. All right. So from here, if I do this, I'm going to have L equals to PL all over TE into B1 B2. Then from the law of logarithm, know that ln of ln A minus ln B is equal to what? Ln of A all over B. So this is going to be ln into B1 all over what? B. So explain this side. The total elongation is nothing but L equals to P L all over what? All over B1 minus B2 divided by thickness E. So divided by length of B1 all over E. This is formula derived from the total elevation of the rectangular course. So learn that new thing. Don't forget to share this with your friends who might be, and don't forget to also join our WhatsApp group. Find the link in the description. That are watching this for the first time, don't forget to subscribe so that you get notified whenever we post content, design content, and mathematical content that you might be